If you are looking for a shortcut to deep foundational knowledge, well, you are in the right place. Today, we're taking a look into the massive work of Mortimer Adler's Syntopicon.
And we're focusing on just one of its 102 great ideas, astronomy.
But not in the way you might think.
Right. We're approaching this not as a technical science, so you won't hear us discussing, the latest findings on black holes or supernovas.
Instead, we're looking at it as an intellectual tradition.
Exactly. We're analyzing how the study of the stars, as Adler frames it, acts as a window into the structure of the cosmos and, maybe more importantly, the human mind's long search for order in nature.
That's a huge mission for a single discipline. Adler is basically using the stars as a mirror to chart, well, the entire history of Western thought.
He really is. He connects thinkers across almost 2,500 years.
From the pre-Socratics all the way to modern physics.
And he forces them into one long, continuous conversation about reality, logic, and certainty itself.
To really set the stage for you, it's important to understand that Adler links this discussion into one cohesive story.
Yes. In the Syntopicon, astronomy is conceptually paired with cosmology and the world of nature.
So what does that actually mean?
It means that when any of these authors, whether it's Plato or Aquinas or even Newton, talk about heavenly motions, they're also, at the same time, asking these huge questions about the structure of the whole universe.
You can't separate the mechanics from the metaphysics.
You really can't.
And it's also important to note for you, the listener, that you are experiencing a unique two-host AI conversation powered by Google's Notebook LM for deeper, more dynamic essay analysis. Our mission is to pull out those surprising connections and track how this one discipline, astronomy, became the ultimate test case for philosophical truth over centuries.
And that leads us straight to the great dignity Adler gives this subject. When he introduces astronomy in his Volume 1 essay, he really treats it with a special reverence.
Why, though? Why give astronomy such high status? Is it just because the subject matter, galaxies and stars, is so awe-inspiring? Or is it something more structural?
It's absolutely structural. I mean, the majesty of the cosmos helps, of course.
Sure.
But Adler elevates astronomy because it's the ultimate meeting ground for different intellectual disciplines. It's the science that most perfectly shows how three key fields are forced to interact.
Okay, what are they?
Mathematics, observation, and metaphysics.
So you could think of astronomy as a kind of judge in the court of knowledge.
That's a great way to put it.
Mathematics gives you the abstract rules, observation gives you the hard evidence, and then metaphysics tries to figure out the ultimate nature and purpose of what you're even measuring.
It's interdisciplinary by its very nature, and that makes it the perfect centerpiece for the Great Ideas Project. You just can't discuss the motion of Mars without also touching on the great ideas of cause or matter or time.
The debates about the solar system instantly connect to these core philosophical concepts.
Right. And to track these massive debates, Adler had to set a baseline. So he introduces these two foundational and really opposing classical views that set the stage for the next 2,000 years.
The great rivalry, Plato versus Aristotle.
This split is the core takeaway. I mean, almost every cosmological debate since has been, in some way, trying to find a third way between these two titans.
Okay, let's start with Plato's transcendent view. What was he really trying to solve with astronomy?
Well, Plato offered a fundamentally metaphysical and transcendent account. For him, the heavenly bodies, especially their perfect eternal circular motions, they mirror the eternal forms.
The ideal blueprints of reality.
Precisely. So astronomy isn't really about physical measurements so much as it's a route to contemplating a perfect intelligible order that exists beyond the messy visible world.
So when a Platonic astronomer looks up, they're not just seeing gas and rock, they're seeing these distant, perfect mathematical objects.
Exactly. The whole goal is to use those visible motions to unlock the pure ideal forms that are the true reality. You see this in works like the Timaeus and especially the Republic, where he talks about mathematicals training the mind away from the physical.
And then Aristotle, his own student, comes along and just turns that view right on its head.
He really did. While Aristotle gets equal weight, his account is teleological and immanent.
If Plato was looking through the stars,
Aristotle was looking at them. For him, the heavens show the natural motions and sort of the inherent purposes of their own unique substances.
can you break down that word teleological for us? What question was Aristotle asking?
He was asking, what is the natural purpose of that star or that celestial sphere? Not what's the perfect math that describes its movement. The celestial spheres are just part of a finite, ordered cosmos, and their perfection is inherent to their material.
So it's not a reflection of a higher realm.
No, it's not. He gets into this in works like On the Heavens and the Physics.
Okay, so Plato says the heavens are perfect because they reflect God's perfect math, which is outside the cosmos. Aristotle says the heavens are perfect because the stuff they're made of is intrinsically perfect, which is inside the cosmos.
That's the split. Transcendence versus immanence. It defined the next 1,000 years of thought. It established the whole conflict.
And the Syntopicon uses this baseline to track the trajectory of revision.
Yes, and this is where it gets really interesting.
You have the Hellenistic thinkers like Ptolemy trying to refine the observational models.
Then you get the medieval era and Christian thinkers like Aquinas who are struggling to reconcile Aristotle's finite world with the theological need for infinite transcendent God.
And then the early modern era just completely reshapes the whole playing field.
A total paradigm shift.
It was
The work of Copernicus, Kepler, Galileo, and Newton. It turned astronomy from this blend of physics and metaphysics into a rigorously mathematical, experimentally grounded science.
It was sort of the dethronement of humanity, in a way. The conversation moved from what's the purpose of the spheres to what's the mathematical law governing their motion.
A massive philosophical upheaval. I mean, Copernicus didn't just move the Earth. He broke those crystalline spheres that Aristotle had set up.
And Kepler replaced the perfect circle with the ellipse.
Right, showing that the celestial realm wasn't fundamentally different from the earthly one. And then Newton unified it all, showing that the same law governs a falling apple and the orbit of the moon.
So what were the major philosophical flashpoints that the Syntopicon uses to organize all this?
Well, the primary debates, the ones that track continuity and reversal, they concern three huge concepts. First, the switch from geocentrism to heliocentrism.
Earth-centered to sun-centered, a physical change with massive psychological implications.
Huge. Second, the debate over a finite versus an infinite universe. Is there a boundary or does it just go on forever?
And the third,
The changing status of celestial matter. Was it perfect and unchanging, or was it subject to the same laws of gravity and decay as everything here on Earth?
synthesizing this many perspectives over thousands of years and across opposing worldviews, I mean, from Aristotle's world to Newton's, that requires some incredibly careful analysis.
It does.
Which brings us to a moment of reflection. If you want more detailed analysis, summaries, and critical thinking inspiration for complex ideas like these, you should check out Mindful Moments, our YouTube channel offering AI essay analysis, summaries, and critiques. It's all about inspiring reflection and rational thought.
And that careful analysis is exactly what Adler's epistemic framework is designed for. He recognizes that over time, humanity has treated astronomical claims very differently. For Adler, astronomy becomes the ultimate test case for moving through four distinct stages of knowledge.
Okay, let's break down that ladder of certainty. Walk us through those four stages.
Let's start at the bottom, with the easiest stage to enter, opinion. This covers myths, folklore, speculative cosmologies, and frankly, anything that hasn't been rigorously tested. It's what we feel or intuit about the heavens.
We still have plenty of opinions about the cosmos today.
We certainly do. But the next stage up is knowledge. Knowledge is defined by having predictive mathematical models.
So like the Ptolemaic system.
Exactly. It was mathematically complex, but it let you predict where the planets would be. It offered reliable, useful knowledge, even if the underlying assumption about the Earth being central was wrong. Knowledge means a system works and is predictive.
So knowledge is defined by utility and prediction. What comes after we know how to predict the motions?
The third stage, which is much harder, is understanding. This requires integrating astronomy with broader physics, metaphysics, and theology.
You have to ask if the theory makes sense with everything else you believe about, say, time, cause, and matter.
Yes. When Galileo saw mountains on the moon, he was challenging the metaphysical understanding that celestial bodies had to be perfect, smooth spheres.
And the final, most ambitious stage.
Wisdom. Wisdom is where you take those hard-won discoveries and judge what they imply about our place in the universe and our ultimate purpose. It's where you move past mere prediction into meaning and values.
Does the discovery of an infinite universe change how we view human limitations? That kind of question.
That is a question of wisdom.
That progression from opinion to a unified wisdom, it gives us a perfect lens to evaluate competing claims. And Adler suggests specific criteria for this, right? 3 distinct truth tests.
Absolutely. The 3 key tests force you to look at a theory from different angles. First, there's correspondence.
The empirical test. Do the predictions actually match observation?
That's it. Is the math consistent with what we see in the telescope? If your model says an eclipse happens at noon and it happens at 3, your model has a problem with correspondence.
Pretty straightforward, the modern scientific test.
Right. But it's not enough. The second test is coherence. Does the new cosmology fit logically with broader physics and metaphysics?
So for Kepler's elliptical orbits, the question wasn't just, does the math work?
It was also, does this concept of motion cohere with our broader definition of natural forces? It's the test of internal consistency across all knowledge. No separate rules for Earth and sky.
And the third test.
The third is the most practical, pragmatic success. Does the theory actually guide practical activities?
Like navigation or making calendars?
Exactly. Or even developing technology. A theory might be correspondent and coherent, but if its math is too complicated or it fails to guide practice, its utility is limited.
What's so fascinating here is that Adler refuses to keep astronomy purely theoretical. He links this study of distant stars directly to ethical and civic life. Most people don't think cosmology influences democracy.
But that's the ultimate insight of the great idea structure.
Yeah.
Everything is connected. Adler forces you to ask these profound questions that bridge the heavens and the earth.
Like what?
For instance, the framework invites what you could call golden rule questions about your cosmology.
Explain that connection. How does a view of the universe affect the golden rule?
You have to ask, how do certain cosmological pictures support or undermine human dignity, responsibility, or humility? If your cosmology implies that humanity is just an accident, meaningless, governed by fatalistic forces.
Does that undermine moral choice?
Exactly. And more importantly, would the ethical implications of your chosen cosmology be acceptable if those roles of agency and responsibility were reversed among different peoples or eras?
That is a powerful way to check our own intellectual biases. If your view of the universe makes human freedom impossible, you have to seriously ask if that outcome is universally justifiable.
And that ties right into the civic dimension. The framework invites us to use a sort of preamble-style analysis.
Asking if these world pictures can promote the general welfare and secure the blessings of liberty.
Yes, if a cosmological view fosters superstition or fatalism, or the belief that stars dictate our lives, then it actively hinders thoughtful self-government, which relies on rational choice and responsibility.
So the Syntopicon uses astronomy not just as a physical science, but as a discipline that forces us to study ourselves, our constraints, our responsibilities, our capacity for knowledge. It really transforms it from a science of measurement into a profound philosophical quest.
Moving us from the easy ground of opinion right up to the difficult peak of wisdom. And considering the complexity of models today, dark matter, dark energy, multiverses, the debate is still raging across all 4 of Adler's stages.
So we'll leave you with this final provocative thought, building on that progression. In today's astronomical debates about the ultimate fate of the universe, where data is still incomplete and theories conflict, which of Adler's 3 truth tests, correspondence, coherence, or pragmatic success, do you think is currently the most valuable in moving us closer to wisdom? Or perhaps the most neglected? Click the link on screen for the in-depth essay summary, subscribe, share, purchase via link, and think rationally. See the many genre-based book podcasts at Mindful Moments. Nourish your mind on the go.